1. Tensile test. We choose pure aluminum, aluminum alloy, and copper monofilaments that are 30 centimeters long and have an external diameter similar to the testing samples. They're marked by the same distance and are tested on the tensile strength tester. Fix the pure aluminum monofilament and set the equipment. Press the drawing button stop till the monofilament breaks. Record the number on dial. Clearly, as shown in the experiment, the pure aluminum wire is fragile and breaks easily. Get a copper aluminum monofilament. Repeat the experiment as before. The test shows that copper wire is better than pure aluminum ones because the tensile behavior of copper wire is much better than pure aluminum and the breaking elongation can reach a basic level of 25%. It takes more time to break the copper monofilament. Then I acquire a rare earth high iron aluminum alloy monofilament and repeat the test as before. The tensile behavior of this one is much better than the former two, as the time taken to break it is much longer because the aluminum alloy has the features of high elongation and is easy to draw. The elongation is basically above 30%. Measure the length of the three broken monofilaments respectively and calculate by the formula that the elongation at the break of aluminum alloy is 32%. 2. Flexing test. Get 10 cm long aluminum alloys, pure aluminum, and copper monofilaments to compare their fatigue resistance properties on flexing tester. Turn on the power switch, press the start button to start test. Bend it back and forth at 90 degrees until the monofilament fractures. Because the fatigue resistance property of pure aluminum is poor, the bending rate of it is not high, and it breaks quickly. The final number is 16. Get a copper monofilament, fix it, adjust the number to 0, and repeat the former test. The fatigue resistance of copper is relatively better than that of pure aluminum. After repeated bending, the final number is 22. Take an aluminum alloy monofilament, fix it, and repeat the test. The rare earth high iron aluminum alloy has much better fatigue resistance properties and does not break after a long time of being bent back and forth. The final bending number is 35. 3. Combustion test. Get a 40 cm long low smoke, non-halogen, non-flammable aluminum alloy cable. Put it under a flame between 900 to 1000 degrees to test. Fix the aluminum alloy cable. Light the blowtorch. The temperature of flame is between 900 to 1000 degrees. When burning, the cable will not continue ignition and will drip. After long time burning, part of the cable under the flame becomes charred and releases only a little smoke. The cable extinguishes when the fire is extinguished. The conductor within does not heat. The smoke release is not poisonous or smelly. Uncover the cracking-resistant sheath of the burnt part, and the conductor within will remain intact without any damage. Through this test, it is clear that the eco-friendly rare earth high iron aluminum alloys cable is sufficiently suitable for a key role where fire control safety is concerned. The aluminum alloy cable has passed the NFTC test, passed the fire temperature